I am Aftab Alam, Maths faculty in Motion Education. So today we are going to talk about sequence and series. So first of all I will discuss about sequence, then series. So what is sequence? Any collection with identified first term, second term and so on. For example, we can take any random number here. So 1, 10, 57, 87, log 7 to the base 2 pi, means we can take here any random number, means that is mathematical quantities here. So here we are differentiating by comma. This is our first term, this is our second term, this is our third term. In this way it is going. So this lower subscript should be always natural number. This should be always natural number. So this is about sequence, any collection with identified first term, second term and so on. For example, 1, 10, 57, 87, log 7 to the base 2 and pi, means here we can take any mathematical quantities here. So there is no rule for sequence. Here we are differentiating by comma. This is our first term, this is our second term, this is our third term, this is our third term. In this way it is going. Okay, so this lower subscript should be always natural number. Our next heading is series. So series, it is the represented sum of a sequence. So I am taking same example as previous one, means 1 plus 10 plus 57 plus 87 plus log 7 to the base 2 plus pi, means here what we are doing here in series, means in same example I am taking here we are differentiating with plus sign. This is our first term, this is our first term, this is our second term, this is our third term. In this way this is our fourth term, this is our fifth term and this is our sixth term. So T1 plus T2 plus T3 plus T4 plus T5 plus T6. In this way it is going. So see this here, what is the main difference between sequence and series? In sequence we are differentiating by comma, in series we are differentiating with plus sign. Okay, so we can use here summation also. R is equals to 1 to 6, means lower limit R is equals to 1 is going and upper limit is 6. So TR, if you put here R is equals to 1, then you will get T1 plus, if you put here R is equals to 2, then you will get T2. In this way, means T1 plus T2 plus T3 in this way up to T6. Means what is the highest limit here? So limit is 6, so maximum we can go to T1 plus T2 plus T3, in this way T6. Next heading is progression. What is called progression? Sequence with definite rule. Sequence with definite rule where we follow a fixed rule or pattern. Means what is called progression? Sequence with definite rule where we follow a fixed rule or fixed pattern. For example, first example I am taking 1, 2, 3, 4, 5. In this way it is going. So see this, from this example we can say that every next term is added by 1. After that, what is the second term? See this, here if you add plus 1 then you will get 2. If you add here plus 1 then we will get 3. In this way, if you add plus 1 then we are getting here 4. So from this example we can say that means every next coming term is added by plus 1. After that, second example, x square, x raised to the power cube, x raised to the power 4. In this way it is going that. So from this example we can say that every successive term is the product term with x. Means see this, if you multiply here by x, then we will get x square. If we multiply here by x, then we will get x cube. In this way it is going there. Means we are following a certain rule here. Means we are following here a fixed rule. Means here we are adding +1, again +1, then we are getting a number. So here in progression, the main difference between sequence, series and progression, means in sequence there is no fixed rule, means we are identifying by comma. In series we are identifying by plus sign. In progression, actually here we are following a some rule, means a fixed rule is we have to follow a fixed rule here. Our next heading is types of progression. Types of progression. First type, arithmetic progression. Arithmetic progression AP. Second, geometric progression. In short you can say GP. Third one, arithmetic cosmetic progression. AGP. In short you can say AGP. Fourth one, harmonic progression. Means in short you can say HP. And fifth one, miscellaneous problems. So first of all I will discuss about arithmetic progression. So what is called arithmetic progression? Progression whose term is increased. Progression whose term is increased or decreased by a fixed number. Progression whose term is increased or decreased by a fixed number, that fixed number is called common difference. If A is a first term, and D is the common difference, then a standard appearance of an AP is A plus D, A plus 2D, A plus 3D. Okay, in this way, this is our first term, this is our second term, in this way this is our third term. So I want to write Tn term. So see this is our first term A, this is our second term T2, means A plus D, this is our third term T3, means A plus 2D, this is our fourth term, means T4. So what is the coefficient of D here? We can write as in this way, 0 into D, A plus 0 into D, here A plus 1 into D, A plus 2 into D. So see this is our first term, so we can write as 0 as 1 minus 1. Here we can write as coefficient of D is 1, so we can write as 2 minus 1. Coefficient of D is 2, so we can write as 3 minus 1. Here coefficient of D is 3, so we can write as 4 minus 1. So see this, here coefficient of D is 0, so we are writing 1 minus 1. Coefficient of D is 1, so we are writing 2 minus 1. Coefficient of D is 2, so we are writing 3 minus 1. This is our first term, so we are writing 1 minus 1. This is our second term, so we are writing 2 minus 1. This is our third term, so we are writing 3 minus 1. In this way, if I want to write Tn term, so what is the Tn term? A plus n minus 1 into D. So this is our last term. This is our last term, and it is denoted by L, or you can say general term of AP, or you can say nth term of AP. So Tn is equals to A plus n minus 1 into D. This is our formula for nth term of AP. General term of AP means Tn is equals to A plus n minus 1 into D. Our next heading is sum of n terms of AP. So let's suppose Sn is equals to A plus D means second term. First term means Sn is sum of n terms of AP. A first term, A plus D second term, after that third term A plus 2D. In this way, what is the nth term? A plus n minus 1 into D. This is our nth term of AP. Okay, so reverse all the terms and add them. So what is the last term? A plus n minus 1 into D, plus what was the second last term? So A plus n minus 2 into D. After that, what is the first term here? So first term is A, so reverse all the terms here and add them. So I am adding this. So Sn plus Sn, 2Sn, okay, is equals to A plus n minus 1 into D. So 2A plus n minus 1 into D. Okay, after that, if you add this second term and second last terms, then you will get 2A plus n minus 1 into D. Okay, after that, if you add last term plus first term, so you will get here 2A plus n minus 1 into D. Okay, so these terms are repeating n times. This 2A plus n minus 1 into D is repeating n times. How? See this, if 2 plus 2 times repeating, so we can multiply 2 into 2, 2 plus 2 plus 2. This term is repeating 3 times, so we can multiply in this way 3 into 2, 2 plus 2 plus 2 plus 2. This term is repeating 4 times, so I am multiplying with 4 into 2. So these terms is repeating up to, means this terms is repeating n times, so I can multiply here n into 2A plus n minus 1 into D. Okay, 2Sn is equals to n into 2A plus n minus 1 into 2. So divide both sides by 2. So we will get Sn is equals to n by 2, 2A plus n minus 1 into D. So this is our formula for finding the sum of n terms of AP. And another one you can do in this way, Sn is equals to n by 2 here. So 2A we can write as A plus n minus 1 into D. So n by Sn is equals to n by 2, A plus n minus 1. This is last term. So we can say A plus L, n by 2 here. Sn is equals to, so Sn is equals to n by 2 into A plus L. Means if last term is given, then we will use this formula. Otherwise, this formula is sufficient. Okay, thank you.